right, it's 2:10. We'll go ahead and get started. My name is Mike Allison. I'm a senior director in our NAND product planning team at Samsung, where I mostly focus on standards, and NVMe is one of those ones that I'm doing. I'm here to give a little presentation on what we're doing with some PCIe and dealing with migration. This is a continuation. Last year at this event in Texas, I brought in controller migration. I'll go over that a little bit. And this is just a continuing story of doing the migration within NVM Express. I'm going to be presenting a proposal that when NVMe gets up in front of these conferences, they have a what's our plan of what we're doing, and migration is on that plan. What I'm talking to about today is still in development, but we wanted to bring it forward to show you the kind of direction we're going, give a high-level overview of what we're trying to accomplish and the problems that we're trying to solve. But I do encourage you, if you're interested in this, please come to NVMe. We'll be talking about this tomorrow in the meeting, so please come forward and speak up and help us get it to completion. As I begin, last year I brought in, what we brought in is controller migration. This capability is in the current NVMe base specification version 2.2. And what it does is it allows for the live migration of a VM running in one server where it's connected to an NVM subsystem where you can put SSD there, and how we migrate it to another server on another SSD. So you can see there, you have a VM running, it's doing I/O to a namespace through a controller. What can happen is you can have a managing, what we call the migrating management host that is talking to the system through another controller attached to the namespace of where we want to migrate it to. And what it can do is take the allocated LBAs. These are the LBAs actually written, not any LBAs that are deallocated. And it can actually migrate them from one system over to the next and put it into the namespace on the other side. Now what I showed was that the I/O stopped at the end. The live migration is actually happening while the VM is happening. So you're copying data from over there, and hopefully at the end when you do it, there's just a little bit left of transient data to copy it over there. Once you've done that, you can now we can talk about, well, how do I get the controller state? Because the controller's doing commands. The VM doesn't know that this is happening, and it has commands it has submitted. At this point, the controller should, Y there in the source NVM subsystem should be stopped, and we can then go and get the controller state and migrate that over into the controller we're going to use. And now we have the state there, we have the namespaces there. The migrating management host can then move the VM over there and continue operation, and now we've migrated. But there's some problems with this picture. I hope you saw it out. The biggest problem is we have identity problems. Our goal is that the VM doesn't see any changes, but as we migrated from one system to the next, we may have a different controller that we migrated to. We went from controller 1 to controller 10, or whatever the controller number is. And also, the host can't pick the namespace identifiers when you create a namespace. So unless namespace B there was actually namespace A, then the VM may see a different problem. One of the ways of getting around this problem that's done today is hypervisors actually are used to trap commands coming from the VM, modifying that command to address the changes that have occurred due to the migration, send it down to the controller that you're now running on, get the response back, fill in the data so the VM doesn't see any changes, and send it back. The goal of what we're trying to do is not have to do this. We want the VM to talk directly to the controller, is what our goal is. As part of doing that, what we wanted to do is look at what capabilities already exist in NVMe. In NVMe 2.0 or 2.1, I can't remember, but a new feature came in. It came in from a technical proposal called Scalable Resource Management. And it was addressing a problem where we have large NVMe over Fabrics storage devices that are too hard to manage. And can we break that up into smaller systems so that the administrators, for what they're using, that storage system can manage it at a micro scale instead of a big old macro scale. And so they defined this thing called an exported NVM subsystem. It's really a virtualized NVM subsystem. We use the word exported. And the words that I'm using in this presentation are in the specification. You'll see them there. We'll talk about underlying and we'll talk about exported. It just means it's a real controller that is able to become an exported controller and stuff like that as I go through this. They define the exported NVM subsystem. This is the virtual NVM subsystem. And in NVMe over Fabrics, they use a port. And when you get a port, you can get a controller. When you have a controller, you can do commands there. And then they created exported NVM subsystems. And when they create these entities, what's really happening is the host that is connected to the underlying controller only can see the exported entities that that underlying or port is connected to. So when that host there in purple that I have says, go give me the list of namespaces, it's only going to see the exported namespace NSID3 in this particular case, even though the real namespace in the system is NSID1 because we are exporting it there so we can use the mapping there and give a consistent look and feel to the host. Okay? So what we've done is we've looked at this for NVMe over Fabrics and we said, well, for PCIe, we want to do migration. So let's take the same concept here. And so what we've done is we don't have ports with PCIe. We only have controllers. So our direction right now is we're going to create an exported controller, just like you did with a port. And then when you create the exported controller from the orchestrating host, it's going to say, go create an exported controller, put it in this exported NVM subsystem, and he's going to provide the identifying controller identifier of the underlying controller, the real physical controller that the host would connect to, and what is the controller ID that we want that host connected to there or the VM connected there to see, so we can manage that. And that's already done with the namespace identifier. When you go into the NVM spec today and you say, oh, I'm going to go look at the manage exported namespaces capability, you're going to say when you create the exported namespace, you get I specify the identify of the exported namespace. So from a PCI point of view, if you were to say, okay, this host that is connected to the underlying controller, when it goes and says what is in that system, it's only going to see the exported entities that are contained in the exported NVM subsystem to which the underlying controller is connected to. You could think of this as a virtual SSD within an SSD at this point. Okay? So if that host says, give me a list of controllers, he's only going to see controller ID 0. Even though he's physically connected to controller ID 1, any data coming back to him is going to say, I'm controller 0. So we're controlling all of that mapping between real controllers and what is presented to the host, and the same with the namespaces. Now, along with that is it's just not the controller identifiers or the namespace identifiers. If you look at NVMe, there's an identify controller data structure that comes back that provides a whole bunch of information. Vendor ID, unique IDs for worldwide unique IDs across the board. Well, as we're doing migration, we don't want those things to change either. I don't want somebody to say, okay, hey, I'm from Samsung, so don't go to a Samsung SSD and you say I'm the Samsung SSD and migrate that to another vendor's SSD and then he says I'm Samsung. That wouldn't be a good idea. So we're going to allow for these additional attributes to be defined in the exported NVM subsystem that can override those values to let the host say, for that VM, this is what I want you to report for the unique IDs. So that way it can be controlled by this orchestrating host about what I want to present to these virtualized hosts. So let's now talk about the migration. How does the migration work? So here I have two servers, server on the left. I have him host 1. He's running a work in an exported NVM subsystem. He has one controller, one namespace he's doing work through. And on the other side, I have a server, and he's already got another exported NVM subsystem over there, host 2. And he's already using some of the underlying entities that's on the left. And that was done on purpose to magnify the problem we're trying to solve. So to do the migration, what happens is, on the destination side, you need to create an exported NVM subsystem that mimics the same number of exported entities of the exported NVM subsystem you're trying to migrate. So you create your exported NVM subsystem. You can create the underlying namespace. And then once you've done all that, you can now do the exported namespace within the created exported there and align it to the namespace that you're doing. And then you can align the controller. So now the exported subsystem X that I have on the source equals in terms of the components of the exported entities that I have in the destination. Now, if you'll notice here, now my identifiers are fixed. So now, if the host connects to the underlying controller in controller 2, which I'll get to in a minute here, when he connects to that, he's only going to see the same underlying features. So we solved that problem of controller identifiers and namespace identifiers. Now, as part of migrating the namespace, we're still going to use what was done in TP4159 for doing that live migration, because that's really doing the underlying namespace migration from one system to the next, and all that live migration that was built when we did that particular proposal all adapts here into this situation. What's a little bit different here is now what we want to do is we want to create this exported subsystem state. This is going to define everything else about the subsystem that the VM sees, so we can migrate that over. And we're going to provide capabilities to abstract that and then put it back into the other side and say, hey, here's your state that was equal to the state from the source. And now this exported NVM subsystem Z should match the exported NVM subsystem X. Finally, the hosts, or the orchestrating host, can migrate the host 1 over there, and now he can say start running again, and he can continue where he left off. And the host 1 should not see any changes of data due to the migration to a different server. Okay? Now, there were commands in there that were done, and he may not have seen that, but it'll just be as if he was continuing to run. There still is a time when the controllers, physical controllers on the source, are actually suspended, which was supported by TP4159, in which case you go get the final state and move it over. And then you can, when you get the final state set into the target side, and then you can resume and you can continue operation. Just like what was done for TP4159, this exported NVM subsystem state, we're going to set it up so it can be done live. What I mean by that is we assume that there's going to be a lot of data in there that may be static and not changing. We'll allow them to read it, and if they want to read it live and do updates across there, they can. But the final state, you still have to always copy the final state once the controllers stopped operating for the host. And from that, what did I just do? Okay, I hit the wrong button. So after he's done the migration, then he can go over to the orchestrating host on the source side, and he can start removing everything that was created and then use that server for doing maintenance or for other operational features and create other exported NVM subsystems. So with that, we're showing you the direction that we're trying to do for this live migration and how we're trying to make it so that the VMs or the hosts that are connected to these underlying controllers and these exported controllers, they're not going to see any changes in their data. They shouldn't even know that they've been migrated. That's our direction right now. My plan is to get this finished up here, so that way by SNIA SDC, I want to come to that and say, here's the final product, here's the new commands, here's how it works, and give the host perspective, what does the host have to do in order to manage this as we go forward. Okay, so that's the end of my slides. Questions? All right, David, go ahead.
All right. Nice talk. Nice talk, Mike. First, what should be an easy one. You've shown a combined migration case in which both the computation and storage switch servers. Does this work for the storage-only migration where the computation stays in the same server, but I want to run it against a different SSD?
Sure. There's nothing prohibiting it. So it's just going from one controller to the next, and you can create the exported NVM subsystem in the same SSD if you wanted to. There's no provisions for that. The other thing I didn't mention is I use the word controller. Okay? It could be an SROV physical controller. It could be a physical NVMe controller. The physical controller type doesn't matter. What we're saying is any controller in the system that is deemed as migratable can adhere to this, okay?
So you can move to different SSD same server. Now the harder question. How do you, this works great if the VM's already running against a namespace and exported subsystem. So that's fine with Greenfield where we create those. How does Brownfield work? Or how do I P2V and get from a non-exported subsystem to use the exported subsystem basis that makes all of this possible?
Well, the way we're doing it is you would have created the initial workload using an exported NVM subsystem from the very beginning.
That's the Greenfield case.
Yep.
I'm asking about how do you do P2V in the Brownfield case? It's not an easy question.
It's not an easy question, and I don't think we've really addressed that to that, and that's something we could talk about. Okay? What I can do is we are taking into account that we have to deal with the fact that I may be migrating to something that doesn't support a capability that is possible to be supported on the controllers that you're moving to. What we're going to do is allow the host to say, of those things that this exported NVM subsystem supports, turn these things off so I can migrate it to my different vendor types that I have. Now, it's going to be up to the orchestrating host to make sure that all that matches. We're not magically going to just stop doing things. The orchestrating host can do whatever he wants to do, but we are going to say, hey, if you tell me to do something I can, I'm going to reject that command. And I'm an SSD guy, so we would reject that. So those are things that we're really doing is we're providing services for the orchestrating host to manage this the way they want to manage it. Okay? Okay.
Do you reject that command in a way that the hypervisor can take that command over and virtualize?
They could if they wanted to. At that point, they would just say, go run with this, and they trap it and hide it if they wanted to. That would be outside of NVMe. All this hypervisor trapping is out right now outside of NVMe, so we don't even know what's occurring. And they're free to do stuff in the hypervisor as they deem fit if they wanted to. Well, because what the goal is to get rid of the hypervisor trapping the admin commands. They want the VMs to talk directly to the controllers and stop trapping everything. All that manipulation and translation of all the commands, they want to push that down into the controllers themselves, and they can set up everything so it's done automatically. Yes?
Does the hypervisor see the physical controller ID or namespace ID?
Let me back up there. Let me back up to, well, I guess. Good question. All right, so here we are for the exported. This orchestrating host is connected to a controller. He sees everything. He sees all the physical controllers. He is the one programming the mapping of what should be exported and what shouldn't be exported, okay? So one of the things is if he goes and sets up something, we're going to give him the ability to say, what did I set up? Because if you go look at TP6011 right now, you can set whatever you want up, but you can't read it back to say what you set up. So the orchestrating host can see everything, and if you'll see there, he's outside the exported stuff, so he can see all the controllers and everything else, okay? He also has the ability to say, I can take controller X there and not use them as an exported thing, so whoever connects there can see the whole system if they wanted to. We're letting the orchestrating host decide how they want to use this capability. Okay? Yes. Yes. We're being really careful. I'm not trying to say how to build a hypervisor or how the host stack works. We're just saying who's ever connected to this controller that's managing everything. So in SRIOV, I would assume the primary controller is the one who's connected to the orchestrating host doing everything, and then the secondary controllers are all controllers that become underlying controllers and can be migrated, as an example.
And the use case is really VM migration. Is there another use case for this? Like in a container world, we would be.
So there are some use cases, I think, just from, let's take the NVMe over Fabrics. Maybe it's easier just to manage these things if you create these virtualized SSDs within there and you're not worrying about the whole box. You get this controller and these namespaces and you don't see anything else. You can't accidentally do a command that may be beyond the scope of what you want to do. So there are some features that could be taken into account. We're focusing on the migration aspect, but there's multiple uses that could be done.
Another example that's so wrong on containers. Just because you're running containers doesn't mean you don't have to do server maintenance.
Correct.
It is still valuable to lift the whole workload off of one server, put it on another server, and do something like update the BIOS.
You could probably take all that state data, move it off, save it off somewhere, come back in, shut it down, bring it all back, play it back, and keep running from the other end. Yep.
Hypervisor world that applies here.
Yep.
So which D part defines the data migration, the propagation DL, and store rights, and application?
So TP4159 created controller migration, which we also did namespace migration. They're really two separate things. So you can say, hey, I'm going to migrate a namespace, and I'm going to start, and now we have the ability to tell you to get the static data of the namespace at the start of live migration, so you can copy that over, and then we'll keep track of every LBA that changed from that point, so you could play it back. Then when you stop the controllers from operating, you can get the final changes and copy them over. That's independent of controller migration. It was to be used for the overall migration, but you could also use that for copying a snapshot if you wanted to. So we on purpose in NVMe, it's really a separate capability within NVMe. We have some people who want to do controller migration, and because they're using NVMe over Fabrics, they don't have to migrate the actual namespaces. They only need to migrate the controller state. And so we're separating those out for those purposes. That's already in NVMe base spec version 2.2 that's out today. It came in 2.1.
How about video feed? Like, maybe, not for Micron, right? So maybe Micron restricts certain features or logs on the VF that Samsung doesn't restrict, right? So if we migrate into a vendor, how do you control that?
So this is where the orchestrating host is going to have to know what is my capabilities for migration. And they're going to say, across all these things that I'm going to use, let me get a drink of water. Well, we're going to allow you to turn off features that are supported to there, but I can't turn things on I don't support.
This conversation is sliding down the slope towards what hypervisors call virtual hardware and virtual hardware versions.
Yep.
And all this trend to keep going here, you will reinvent something with the whole lot of virtual hardware versions.
Right. So things that are, you can think of it this way, things that when you have a controller, you advertise, I don't know if I'm going to be used this way or physical, and I may have a subsystem scoped feature. Maybe for these VMs, I don't want to expose that. So we're going to give the orchestrating host that says, hey, for this controller that I'm putting in this VM, say that you don't support that feature. So he can't do that operation. So you build this isolation. For the orchestrating host, he's going to have to understand how he's deployed the various vendor SSDs, what's the commonality set, and then create these with that common set and just say, don't report this stuff over here, don't report the same stuff, and then the VM won't see changes. Okay? My expectation is, as this gets used, they're going to have, well, this VM started when I had a bigger set, and then this one started later when I have a different set. It could be they'll have a variance in that over time. Okay? And as far as the unique IDs, they have to be able to program every one of those just for the fact that you can say, hey, host, give me the UUID you want me for this here, and so when you go over this vendor over here, it's your UUID, and you're not using the UUIDs that may be tied to the companies, because you have to guarantee uniqueness. Because if I can't control the uniqueness, I have to control the uniqueness in my own products. I can't control the uniqueness across other vendors. So it's a fun problem, so please come join us. It's a really fun problem. Any other questions? Really good questions. All right, with that, I thank you.